Yes, welcome back. This is part 3 now. Again, the app rudely interrupted us and stopped the connection, but we're still doing May, June 2018, paper 23. This is Mr. John from explainingmaths.com. So make sure you've seen the other two parts. We have done up to question 19. And I've just subscribed to this app. I think it's a great app, so I'll use it more in the future. So now my videos can be a little bit longer. So we just finished the direct proportion question. So moving on to question 20, and one of our personal favorites, I'm sure, circle theorems. I mean, who doesn't love circle theorems, right? I'm sure you love them as equally as much as I do. And before you dive in these questions, always have a good look now. What is going on? For instance, there's no center of the circle, right? Well, it is there, but they don't show it to you, and therefore you don't have to worry about the arrow. The angle at the center is twice the angle at the circumference. There's also no radius, or there are no isosceles triangles, so don't have to worry about those. I see a bow tie here. So you should say angles in the same segment. However, they don't ask me for the correct language. I can just say bow tie, how much I want. I also see a cyclic quadrilateral. And look, another cyclic quadrilateral over there. Good. And just to make sure, guys, W, X, Y, those are the questions. To find W, you will not need X or Y to find W. And sometimes to find Y, you may need the answer to W or X, okay? But not necessarily, but sometimes you do, okay? But surely for W, you can just find it without knowing X or Y. So they say ABCDE line circumference, la 47 degrees, 85. So let's start with W. So we have the cyclic quadrilateral. However, X, I don't know yet, but also we have the other cyclic quadrilateral, and that angle is 85, and those opposite angles add up to 180, right? So W, and that is a little bit weird, is 95 degrees. I'm going to check that. It's been a long day, and I don't want to make a silly mistake. Minus 85. No, it's 95. Now, I know it's not to scale, but this angle looks acute. But okay, 95 degrees. And put that answer in your diagram. Always useful to do so, because as we move on, X, now again, cyclic quadrilateral, so 180 minus 95, so 85 degrees. And by the way, AEC equals ADC, yeah, so also with angles in the same segment, the bow tie, you could have found X. Then I'll put that one there, 85. And while I do that, I can see to find Y, I look at this triangle, right? 180 degrees, the sum of the interior angles. Take away 85, take away 47, leaves you 48 degrees over there. Now, perfect. Let's continue. Algebraic fraction for 3 points, right? It has a single fraction, so we're going to make sure those denominators are the same. And careful, ladies and gentlemen, there is a minus sign in between. And some of you are going to make a silly mistake here at the end. So just be aware of that. Perhaps write an exclamation mark yourself when you see the minus sign between those two fractions. The first fraction I'm going to multiply by y, because I want to get the same denominator. You don't have to expand the denominator, by the way. Just leave it as it is, minus. And the second fraction I'm going to multiply by y minus 1. That's 1 times y minus 1. That stays like that. Now, if you expand, it's okay, but you don't have to. So you're just wasting time, and maybe you make a silly mistake. So just leave it as it is. The denominator is the same now. So the numerator, y minus y, so that is 0. And now, careful, ladies and gentlemen, it is minus 1. So it is a positive 1 there. So I still use my finger, and I apologize for my short fingernails, and my wife hates me for it. Yeah, but anyway, I can point with my finger still. Minus 1. So a positive 1. And unfortunately, some of you are just going to say minus 1 there at the top, which will lose you that point. Moving on, question 22, sequences. And they're asking find an expression for the nth term of each sequence. So they're not asking for what is the next term. No, they're asking you for the general nth term rule of the sequence. So the first one, it is minus 4 every time minus 4. So it's a linear or arithmetic sequence. Common difference is minus 4, so I write down minus 4n. And then you got to be careful because the first term is 11 and not minus 4. So you have to add 15 to go from minus 4 to 11. But okay, just check your answer. I'm almost 39 and I still check these answers. So let's say term 4. We know it's minus 1. So minus 4 times 4 plus 15. Fingers crossed, minus 1. Fantastic. B. So there's no common difference, and perhaps you see it is, wow, times 2 every time. We call this a geometric sequence, and I have to say they don't occur a lot on IGCSE papers. They're part of the syllabus. I mean, you need to know them, but it's more in A-level or IB diploma program that we really study geometric sequences. But okay, perhaps you just want to remember the nth term rule for a geometric sequence. So you have like common multiplier, or we say the common ratio. The nth term rule is always the first term, so 3 times the common ratio. So by what do you multiply it by? So 2 in this case, to the power, and then it's always to the power n minus 1. Okay, so the first term times common ratio to the power n minus 1. And again, check that. So for instance, term 4, it is 24. So you get 2 to the power 4 minus 1 is 3. No, do it properly, John. 2 to the power 3 equals times 3. 24 indeed. Okay, moving on. 23. I see a non-right angled triangle. Find x. I see 4 points, ladies and gentlemen. This is a cosine rule. And again, usually, most of the times, cosine rule is a paper 4 question, but okay, we do it for paper 2 now. It doesn't matter. It's lovely questions. A squared equals b squared plus c squared minus 2bc cosine of a. By the way, you should actually check first, of course, can you do it by a sine rule, but you can't. Yeah, I've got the teammates, but I don't have a full team anywhere. If you have no idea what I'm talking about, explainingmyhouse.com. I explain the cosine and sine rule in a lot of depth. Now, before I start substituting, I prefer to rearrange first. Okay, I'm looking for the angle 2bc cos a, and some of you will just memorize that formula, but I don't like memorizing, so I just rearrange it on the spot. I mean, memorizing is if you study French or Latin or so, right? Then you memorize your words. But for maths, you can just rearrange it on the spot. You won't make a mistake. Now, cosine of A, you got to be careful. You got to be making sure that they are teammates. So if you look for the angle, A has to be 13. Okay, it has to be 13. B or C doesn't matter. 11, 5, 5, 11. Whatever, up to you. Let's do 11 squared plus 5 squared, doesn't matter. But minus 13 squared over 2 times 11 times 5. Fantastic, let's work that out. 11 squared, 121 plus 5 squared, minus 13 squared, 169 equals, and that divided by 110. So cosine of A, I'll just write that down, equals minus 23 over 110. So to find the angle, shift cos answer equals, and then A, let's write down quite a few decimals, and then we round, it's an angle, so 1 decimal point, 102.1 degrees. Beautiful, lovely questions, cosine rule. I mean, you know you're going to get it, so you can prepare for it, and then you just do it. 24, all right. Yeah, indeed, speed time graph. And then always the first thing you need to check are the units, and ho, kilometer per hour and seconds. Ladies and gentlemen, be aware of that. Always check the units because they are different, hours and seconds. Okay. The diagram shows speed time graph for 60 seconds of a car journey. Yep. Change 90 kilometers per hour to meters per second. That's that 90 kilometers per hour, meters per second. Well, that's nice for 2 points. I mean, 90 kilometers are 90,000 meters, and 1 hour are 3,600 seconds. That's a value that you should know, 3,600 seconds in an hour. Yeah, 60 times 60. So 90,000 divided by 3,600, 25 meters per second. Okay, and I'm just going to change that there as well, 25 meters per second, just to make sure I don't make a silly mistake later. So imagine that. I'm sure when you sit with your parents in the car, or whoever takes care of you, you sit in the car, the amount of times you drive 90 kilometers per hour on the highway, right? Doesn't feel very fast, does it? Well, actually, it's 25 meters every second again that you're traveling. It is super fast. Yeah, so drive safely. Don't go speeding. Don't be ridiculous. Just be a sensible person who takes care of the other people on the road. Okay, moving on. Find the deceleration of the car. So the deceleration is that change in speed over the time taken. Okay, and they want it in meters per second squared. So the change in speed is 25. So you got to use that number 25, no longer the 90, over, and the time taken, it does it in 20 seconds, not in 60 seconds. No, because it starts decelerating when t is 40, into 0 when t is 60. So that's 20 seconds. So 25 divided by 20, it's 1.25. Is it 1.25? Now, if you write down minus 1.25, I wouldn't worry too much about it. However, the deceleration already implies a negative acceleration. So just give that the positive answer there, 1.25. And then, of course, the answer we've all been waiting for, or sorry, the question we've all been waiting for, the distance traveled in those 60 seconds. And you will all know that that distance is the area underneath your graph. Well, you can do two things. Trapezium, find the area of trapezium, or break it up into a rectangle and a triangle and find the areas of those two and add them together. And that's what I will do, because I'm pretty sure that's what most of you will do. So the rectangle will be base 40 times height. Again, that 25, not the 90, because the units need to be the same, plus, and then the triangle, half times base 20, so from 40 to 60, that's a base of 20 times 25, which is the height. 40 times 25 plus half times 20 times 25, 1,250. There we go. Good, moving on, we're almost done. Now, question 25. And with my experience, I know that this is a similarity question. And you may see the same thing, like, oh, that has to be similarity. But perhaps you don't, I can understand that. However, question B, you should surely see that is similarity, right? With volume, scale factor, cube. So that may kind of inspire you to say, then this has to be similarity as well. That's not a guarantee, that's not a universal rule, but in most of the cases it is. And so in this particular case, so they say PQ is parallel to BC, as we can see. These are straight lines. PQ is 8 and BC is 10, and AB, so the whole thing is 9, they say. Calculate PB, so this little thingy. All right, and how am I going to find PB? Well, if I find AP, which is a length in this triangle, if I find AP, and if I subtract that from 9, then I'll find PB. And I always encourage my students to draw that triangle in the triangle separately. Put the letters there, and then you decide on the scale factor. So the scale factor, the corresponding sides, 10 and 8, the scale factor is 8 over 10 times, well, 9 to find AP. So 8 over 10, 8 divided by 10 times 9, what is that? 7.2 indeed. So 7.2 AP is 7.2. So again, similarity, you're looking at scale factor, corresponding sides. If AP is 7.2, then X has to be 9 minus 7.2, which is 1.8. There you go. I'm going to say 2 points. It's not very generous. I mean, I see there's only 2 lines of workings, but it's quite a complicated question, I have to say. But okay, we just got to do it for those 2 points. Then, and this is nice, for 3 points, the following question. 2 glasses, and they're similar. The larger glass has a capacity of half a liter. So put that in the diagram. And the smaller glass has a capacity of a quarter of a liter. There you go. The height is 13 centimeter of the larger one. What is the height of the smaller one? Again, to find that height, we need to find the scale factor. And with volume, it is the scale factor cubed to give you the other volume. And if you have no idea what I'm talking about, xtrainingmaths.com, I explain that in a lot of detail. So what is the scale factor? Cube root of 0.25 divided by half. And that gives me loads of decimals. So you know what I'm going to do? I mean, you could write down the decimals now. Don't round. I'm just going to say a quarter divided by a half is a half. Let me just check that because it's been a long day and I want to make a silly one. Yeah, it's a half. I knew that, but I just wanted to check that. So I'm just going to leave the cube root of a half. Okay, that's my scale factor. So 13 times my scale factor, cube root of a half. So cube root of my answer times 13. So 10.318106884. So write down all those decimals and then you round 3 significant figures, 10.3. Beautiful. Last question already, 26 transformations. And they say to start with, describe fully the single transformation that maps T onto U. So that's important. You go from T to U, not the other way around. And it's for 3 points. So you have to give 3 pieces of information. And I think you will all agree with me. It's an enlargement, because U is bigger. Enlargement. How many times is it bigger? So what is the scale factor? Well, this is 1. That is 2. So that is twice as large. Scale factor is 2. Let me check that just to be sure. This is 1, 2, 3, 4. And this is 1, 2, 3, 4, 5, 6, 7, 8. Correct. So I've got 2 points now. To get a third point, I got to give the center of enlargement as a decimal. So how do you find the center? Well, sharp pencil, 30 centimeter ruler, and then you connect corresponding corners or corresponding vertices with a line, nice and big. So don't just go from vertex to vertex, no, nice and big. And then where those lines intersect, that is your center. And it's always going to be a nice coordinate, okay? Never a dodgy one, and I can already see it over there. I'm not doing a very good job. It's not very accurate, is it? But it's clearly the center of enlargement, 7, 0. Yeah. So don't accidentally now say 0, 7. No, it's X, Y, 7, 0. Last question on the grid. Draw the image of triangle T after a rotation 90 degrees clockwise. I always just draw in the direction clockwise around 7, 3. So this is the center. There we go. And then a piece of tracing paper is always very useful. And trace your triangle. And while I trace it, I'll tell you that with these transformations, it will always fit on your grid. And if it doesn't, so if it's outside somewhere, you've made a silly mistake. So check your mistake and do it again, okay? So it will always fit. So I'm tracing the triangle. There we go. An arrow to the north, so I know once I've done 90 degrees, put my pen in the center and I start rotating. There we go. It's pointing to the right now. So I've done 90 degrees clockwise. And then I kind of, there we go, trace those vertices. And then with a sharp pencil and a ruler, I make my, oh, that's That's terrible. That was not a sharp pencil. There we go. I finish it. There we go. And over here. Perfect. Now let me just check that if I didn't make a silly mistake. And I haven't. That is a beautiful rotation. So that was it, ladies and gentlemen, explainingmaths.com. And it's been a while that we've done some of these questions together. I've just been really busy, but I hope this was helpful. And if it was, then please like and share it with your friends. So this was Mr. John live from Brunei, amazing country. And I want you to take care, to believe in yourself, and to go for it, because you can do it. All right. And try to enjoy the journey as well a little bit, because that's what life's all about, making sure you have some fun. Yeah. Take care and see you later.